All right, guys, here are the answers to homework number 2, chapter 4. All right, let's go over them. The first set of problems, problem number 1, I have to say yes or no if it's in scientific notation. Because of this 27, it is not in scientific notation. The 27 is not between 1 and 10. Right? This number has to be between 1 and 10 for the number to be in scientific notation. This is between 1 and 10. The exponent is an integer, so yes. Here we have a problem with the exponent. This is no. The exponent 2/3 must be an integer. So that one is not in scientific notation because the exponent has to be an integer. Number 4, I have to tell which number is bigger. To tell which number is bigger, I start by looking at the exponent. The exponents are tied, so then I look at the number part, and 4.17 is bigger. In number 5, I have to tell which number is bigger. To start, I look at the exponent, and in this case, this exponent is bigger, so that number is bigger. Putting these in order from smallest to largest again, the first thing to look at to determine which number is bigger in scientific notation is the exponent on 10. So I want to go smallest to largest. This has the smallest exponent, so A is the smallest number. The next smallest exponent is this one, so D would be the next smallest number. Now these two have the same exponent, so they're tied. So I would then look at the what we call the A part of the number, and I have 3.7 and 3.72. Well, 3.72 is bigger than 3.70, so C would be the next smallest and B would be the biggest. All right, I need to write each number in scientific notation. This just means I move the decimal until my number is between 1 and 10. And then I put an exponent on 10, how many spots I moved the decimal. So here the decimal moves 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. Notice that that number, 3.45, is now between 1 and 10. Or another way of looking at it is I have one non-zero digit to the right of the left of the decimal. All right? One digit to the left of the decimal that's not a 0. And since I moved it 9 spots, this is going to be 10 to the negative 9th, right? Negative because it made a small number. Negative because the number got bigger, so the exponent goes down and gets smaller. The next one. I would move the decimal 3, 6, 9, 10 spots. When I move the decimal between the 2 and the 2, I have moved it 10 spots, so this is going to be times 10 to the 10th. This one, the decimal, only has to move 2 spots, so it's going to be 10 to the 2nd, and when I move the decimal there, it's 5.2 times 10 to the 2nd. Number 10, 1, 2, 3 spots gets me 3, right? I couldn't stop after 2 spots because then I'd have 0.3. 3 spots, and so this is going to be times 10 to the 3rd. But again, since this is a tiny number, it'd be negative 3rd because I moved the decimal to the left. Here I'm going to move the decimal 3, 6, 7, 8, 9 spots. 4.28 and I moved the decimal 9 spots, so it's times 10 to the 9th. Here I'd need to move the decimal past the 4, so that would be 1, 2, 3, 4, 5 spots, and I would have negative 5 because I moved it 5 spots, but I moved it to the right, so it's negative 5. This number's already between 1 and 10. So, how do I write it as 7 times 10? Well, how many spots am I moving the decimal? 0 spots. So it'd be times 10 to the 0. Okay, this one looks like it's in scientific notation, but it's not, because this number is not between 1 and 10. So I need to move the decimal 1 spot so that it is between 1 and 10. And remember, when this number gets smaller, right? It went from 32 to 3.2. It got smaller. The exponent needs to get bigger to make up for that. So I move the decimal 1 spot. The exponent would get bigger by 1 spot. That would be negative 4. Number 15 is similar. It looks like it's in scientific notation, but it's not, because this number is not between 1 and 10. So I'm going to move the decimal 1 spot. Now it is between 1 and 10. And because this number got bigger, the exponent gets smaller by 1 spot. There we go. All right, these next set of problems, I need to write an equation in standard form. So I'm just going to move the decimal the number of spots the exponent says. Negative to the left, positive to the right. So this first one says move the decimal 7 spots to the left, right? The negative direction. So 1 spot gets me past the 1, and I'm going to need 6 zeros in there. So 1, 2, 3, 4, 5, 6 zeros, then the 192. And I like to start the number with a 0 before the decimal as well. This says move the decimal 10 spots. Well, right now the decimal is here at the right of the 5. So when I move it 10 spots that way, I'm going to need 10 zeros because I don't have any numbers to go past. I'm just going to need my 5 and 10 zeros. 3, 4, 5, 6, 7, 8, 9, 10. Let's go ahead and put the commas in place. Every 3 digits, right? 50 billion. This exponent is telling me to move the decimal 6 spots to the right. Well, it's 3 spots to get to past the 2, so I'll need 3 zeros to make it 6 spots. So 7, 4, 1, 2, and 3 zeros. Put my commas in, and I'm done. Number 19, the decimal is sitting right here. I need to move it 5 spots that way. So I'm going to go past the 8 and then 4 zeros to make 5 total spots. So 4 zeros and the 8. And I have now moved the decimal 5 spots, and I'd like to start that with a 0 as well. All right. Move the decimal 0 spots. This would just be 2.8. And finally, this one says move the decimal 3 spots to the left. So I'm going to go 1 spot to get past the 8, and then I'm going to need 2 zeros. So it would be 0, 0, 8, 8, and I put my decimal in. There we go, 0.0088. All right, so now I'm adding and subtracting. All right, so I think it's easier to add and subtract when you stack the numbers. So I'm going to make this 7.1 times 10 to the 11th, and I'm going to add. I'll keep the 10 to the 11th, but I will add. The 6 and the 1 makes 7, the 4 and the 7 makes 11. I get 11.7 times 10 to the 11th. That is not in scientific notation, and I'm supposed to write the answer in scientific notation. So let's move the decimal over 1 spot, 1.17. And since this number got smaller, the exponent needs to get bigger, this would be my answer in scientific notation. Here I am subtracting, so let's make this 8.80 times 10 to the 7th. And let's go ahead and subtract. 5 minus 0 would be 5. 9 minus 8 would be 1. That'd be 0. When I'm adding and subtracting, I keep the exponent the same. I get 0.15 times 10 to the 7th. That is not in scientific notation because this number is not between 1 and 10. So I'm going to move the decimal one spot this way and make it 1.5. And since this number got bigger, the exponent is going to get smaller. And there we go. Number 26, I am adding again. So let's make this 9.3 times 10 to the 15th. And when I add that, I get 5. I get 18 times 10 to the 15th. That also is not in scientific notation. So I need to move the decimal one spot to the right. 1.85. And because this number got smaller, the exponent's going to get bigger, and I've got 1.85 times 10 to the 16th. And that takes us to a couple questions here. Let's see. A number that is written in scientific notation looks like this. What can you say about the a value? Well, I can say that the a value has to be between 1 and 10. It can actually equal 1. So the a value has to be greater than or equal to 1, but it has to be less than 10. And what can I say about the n value? N must be an integer. All right, can't be a fraction or decimal. And that brings us to 28. If I added these together, this is just checking to see if you know how to add numbers in scientific notation together. You would add the real part of the number, a plus b, and that would be times 10 to the, and when you're adding numbers, you keep the exponent the same, so it would still just be 10 to the n. A plus b times 10 to the n. Right? That's what I did up, I don't know, that's what I did here. I added the a plus b, and I kept the exponent the same. And then we've got a couple story problems. In this first story problem, it says people in the United States eat 2.7 times 10 to the 9th apples, while people in Canada eat 1.9 times 10 to the 9th apples each year. How many total apples are eaten? Well, that would be an addition problem. So let me set up the addition problem. 2.7 times 10 to the 9th, 1.9 times 10 to the 9th. I'm going to add together the United States apples plus the Canada apples, and that will equal the total apples. I know that this is still going to be 10 to the 9th. 7 and 9 would be 16. It'd be 4.6 times 10 to the 9th. Of course, that number is not in scientific, well, it is in scientific notation. What am I saying? So it would be 4.6 times 10 to the 9th. And don't forget your label. That would be apples. And in standard notation, I would need to move the decimal 9 spots, right? So this would be 4, 6, and 8 zeros. Apples. Let me go ahead and put the commas in. So 4,600,000,000 apples. I should have grown apples for a living. Number 30, I have a spider that weighs this, or a spider has this many cells in its body, while an ant has this many cells. What is the difference in the number of cells? So difference in math means subtract. Let me go ahead and set up a subtraction problem. I can subtract because the exponents are the same. Otherwise, I'd have to figure out a different way to subtract. My answer is going to be something times 10 to the 11th. I need to subtract 6.3. Let's throw a 0 on there. And go 2, 10. 10 minus 5 is 5. 12 minus 9 is 3. And I'd have 0.35 times 10 to the 11th. Of course, that number is not in scientific notation. I'm going to have to move the decimal over one spot and change the exponent. And I would get 3.5. So the number got bigger, the exponent gets smaller, times 10 to the 10th cells. Or in standard notation, I'm going to need to move the decimal 10 spots. So that's going to be the 5 and 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me put the commas in. That would be cells, 35 billion cells. All right, and last up, I want a little challenge problem. I want to add these two things together. The first thing I notice about these two things is that they have a different exponent. So I can't easily add them together. What I'm going to need to do is I'm going to need to rewrite one of them with a different exponent. And it is easier to rewrite the smaller one. So I'm going to go ahead and rewrite this one. I'm going to move the decimal one spot this way, giving me 0.51. And since that number got smaller, the exponent gets bigger. Now I'm ready to add. And I would be adding 2.8 and 0.51 together. My answer is going to be times 10 to the 15th. This would be 0 plus 1 is 1, 8 plus 5 is 13, and that's 3. It'd be 3.31 times 10 to the 15th. So, that's it. 3.31 times 10 to the 15th. All right.